Hi everyone, welcome to your very own math skills lesson. Thank you for joining me again, and let's get on with our 3 activities that we've got planned for today. Okay, so to help us with these activities and help us to explain the maths, we have got some key vocabulary that we are going to practice saying first of all. Okay, let's get started. Part, part, whole, whole, tens, tens, ones, ones, more, more, fewer, fewer, equal, equal. Great. So that is the key vocabulary that will help you with today's maths lessons. Let's get started. So our first activity today is called the house of. Okay, so this house here is the house of this number here. Can you read this number with the person sitting next to you? Yes, it's the house of 32. Fantastic. So the only things that can enter this house are things that are the value of 32. Okay, so we've got lots of different representations on our screen today, but we are only looking for those that represent 32 to go into our house. Okay, so help me out. Should we start with our tens frame over here? We are going to see whether our tens frame can enter the house of 32. What can you see in the tens frame here? Yes, we've got a 10, and another 10, and another 10. Should we count those tens? 10, 20, 30. Fantastic. So we've got 30 over here, but then we've got 31 and 32. Fantastic. So we've got 32. Does that mean our tens frame can or cannot enter our house of 32? Yes, it can enter our house of 32. So let me just drag that in. And there we go. We have one entry into our house of 32. Which one should we look at next? The numicon. Right, great. Again, we can see some tens and we can see some ones. How many tens can we see? 1, 2, 3. Let's count our tens then. 10, 20, 30, 32. 10, 20, 30, 32. Your turn, you count them. Yes, 32. Fantastic. Thank you for helping me. So can that go into our house of 32? Yes, it can. Great. Now I'm going to move over and look at our 10 sticks and our ones cubes. Are we ready? Should we count our tens? How many tens can we see? 1, 2 tens. 10, 20, 21, 22, 23. What does 23 look like? 23. So can this 23 enter our house of 32? No, it can't. Fantastic. Can you tell us what these two numbers have similar? What is similar about these two numbers? Yes, they have the same digits. Fantastic. However, they're in a different place. So they don't represent the same number. Fantastic. So no, we can't have 23 into our house of 32. Shall we move to the coins? Right, so we've got 20, 10 and 5. 20 and 10. We've got 2 tens and one more 10. 3 tens. 10, 20, 30, 35. Does 35 look like again? 3 and a 5. 35. Can 35 enter our house of 32? No, we've got too many. So no, our 35 can't enter our house of 32. Right, great. What have we got here in our part whole model? 15 and 15. Does anybody know what double 15 is? Be really impressed if you do. First of all, let's do double 10. What's double 10? 10 and 10 is? Yes, double 10 is 20. What's double 5? Oh, you're super good at that. Yes, it was. It's 10. So what's 20 and 10 all together? 20, 10 more, 10, 20, 30. So we have the whole of 30. Does that mean our part whole model can go into our house of 32? No, it can't. There isn't enough. So we can't have that in our house of 32. And our last one is 20 plus 11. 20 add 11. So 20 add 11, 20 add 10, 20, 30, add the 1, because we partitioned this off into a 10 and a 1. 20 add the 10 is 30, add the 1, 31. Can that go into the house of 32? No, it can't. Good work, well done. Now I'm going to give you a turn of your own. So now we have the house of this number. Can you tell that number? Go and read it with your tell partner. Yes, we have the house of 24. Fantastic. So we're working with the house of 24. And if the value of what is represented is 24, it can enter our house. But if it doesn't represent 24, it's not allowed in our house. So I'd like you to pause the screen now and decide which of these representations can go into our house and which ones cannot. So pause the screen and off you go. Okay, pause if you'd like more time. Fantastic. Let's start with our money in the corner here. So we've got 20, 21, 22, 23, 24. So yes, your money can go into your house of 24. Well done. What about this number sentence here? 10 add 5 add 5. What's 5 add 5? 10. So it's 10 add 10. So cross that out. 10 add 10. It's 10 add 10. Oh, 20. Yes, it equals 20. So can that go into our house of 24? No, it can't. Well spotted. What about our 10 sticks and cubes here? 10, 20, 21, 22, 23, 24. Yes, it can enter our house of 24. Good spot. What about our Numicon? 10, 20, 30, 44. 44. So no, the Numicon cannot enter our house of 24. Our 10s frame over here, 10, 20, 21, 22, 23, 24. Yes, we can. We can have our 10s frame into our house of 24. And then finally, our part whole model, we've got 12 and 12. Does anybody know what double 12 is? Well, let's have a go at double and 10. So we can double 10. Double 10 is 20. And then double 2 is 4. And 20 and 4 is 24. Fantastic. So yes, our part whole model can enter our house of 24. Well done if you managed to figure those out. So now we're on to our second activity. Well done, one complete. Now we are looking at our tens frames again, but we are looking at how two different parts can make the same whole. So two different parts can make the same whole. So first of all, I would like you to look at our tens frame and check what our whole is. Can you look at our tens frame and check what you think the whole is today? Off you go. Fantastic. Yes, so we've got 10 and 5, so that's 15, 16, 17, 18. So yes, we are working with the whole of 18. So the first part we can see is represented in the red colour. So we've got a red part and a yellow part. Okay, so who can tell me how many we've got in our red part? 10, 5, yes, we've got 15. Fantastic. So we've got 15, and in our yellow part we've got 3. Fantastic. So with that, I'm going to write an addition number sentence and also a subtraction number sentence using my part whole model. Because I know a part of 15 and a part of 3 makes the whole of 18. You say it with me. A part of 15 and a part of 3 makes the whole of 18. Great work. So, my addition number sentence, I'm going to go a part of 15 and a part of 3 makes the whole of 18. However, subtraction, what's different? Yes, we start with the whole. So if I had a whole of 18 and I subtract a part of 3, I'm going to be left with a part of 15. Fantastic. For a challenge, you might see if you can write a different addition sentence and a different subtraction sentence. So pause the video if you'd like to give that challenge a go. Now, I would like you to do this one yourself. So look at the representation here in our tens frame. We are still working with that whole of 18. Can you tell me what the part that is represented by red is and the part that is represented by yellow is? Put it into the part whole model, write your addition number sentence and write your subtraction number sentence, just like we did on the last slide. Pause the video and get that activity done. Thank you. Keep the video paused if you would like more time. Great, so our red part we've got, yes, we've got 10, 11, 12. So we've got a part of 12. And we've also got a part of, oh, I can see 3 and 3. Double 3 is 6. Should we check? 1, 2, 3, 4, 5. Yes, 6. So we've got a part of 12 and a part of 6 makes the whole of 18. Your turn, you say that. A part of 12 and a part of 6 makes the whole of 18. Great, and you might have this number sentence then. You might have 12 add 6 equals 18. Great, a part of 12 add a part of 6 makes the whole of 18. But when we start with the subtraction number sentence, we start with the whole. Yes, we start with the whole of 18. And if I subtract a part of 12, I'm left with a part of 6. So 18 take away 12 equals 6. There are two different ways you could have written that. You could have had 6 add 12 equals 18, and 18 take away 6 equals 12. So give yourself a tick if you manage to get those. We're going to move on. So can you help me with this one? Again, we have our whole of 18 and we are going to find our red part and our yellow part. Can you help me find the red part? Help count with me. Oh, I've got 5, 6, 7, 8. Yes, I've got a part of 8. And my yellow part. Got 1, 2. Ooh, what happens if I move those two down? What can we see? Yes, we've got a completed tens frame. And how much is that? Yes, a completed tens frame represents 10. So we have a part of 8 and a part of 10 makes the whole of 18. Well done, your turn. A part of 8 and a part of 10 makes the whole of 18. Great, so now we've got an addition number sentence. So I've got a part of 8, I add a part of 10 equals the whole of, yes, 18. What do I start with at the subtraction? If I'm taking things away, I need to start with the whole. So I start with the whole of 18, I might subtract 8 and be left with the part of 10. Fantastic. Again, you might choose to pause the video to see if you can write the other two addition and subtraction number sentences that match this part whole model. So pause the video if you'd like to give that challenge a go. Great. Now, we are still working with the part of 18. I've got a bit of a blank tens frames over here and we've got blank number sentences. I want you to try and find one more pair of numbers that make that whole of 18. So we've had 12 and 6, we've had 10 and 8, and we've also had 15 and 3. So we've had 15 and 3, 12 and 6, and 10 and 8. Can you please have a go at trying to find another pair of numbers that still make that same whole of 18? Off you go. Pause the video if you'd like more time. Great. So hopefully you have another pair of numbers that make that whole of 18. And as you can see on my new slide, I have a tens frame of 18. I have the part whole models, the ones we've already done. And I've got some addition number sentences that we've already done. Okay. I now want you to add what you've just done. So some of you might have spotted that part of 14 and a part of 4 makes the whole of 18. So part of 14 and a part of 4 makes the whole of 18. Then you can write that in your addition number sentence. 14 add 4 equals 18. And then you can put that into a subtraction number sentence. So you can go 18, remember we start with that whole, subtract 4 equals 14. So we've got another pair of numbers that make that same whole. Great, well done. So once you've added your extra in there, can you try and find another 2 possibilities to make 18? So 2 different parts that make 18. Okay, so you've got 2 more to complete. Add the addition number sentences in there and see if you can flip and create some subtraction number sentences there. So this is a little bit of a longer activity. So pause the video, work with your adult and see how much you can get done. Off you go. Pause the video if you'd like more time. So some of you might have recognised that a part of 11 and a part of 7 makes the whole of 18. And some of you might be super good with your double facts and have recognised that 9 and 9 will also make that whole of 18. Okay. Then some of you might have gone into your subtraction number sentences and flipped, starting with our whole and taking away a part. So start with your whole, take away a part, and you're left with the other part. Start with your whole, take away a part, and you're left with the other part. And again, that can work with some of the other ones that we have just figured out there. So start with the whole, take off a part, and you're left with the other part. So get your adult to check some of the work that you've been doing. Now, our whole has changed because it doesn't just work with 18. When we have a whole, there are many different ways we can make that whole. So we have a new whole now. I would like you to play around with your part whole model to see which 2 parts make that whole. Which 2 parts make that whole. You can then write it in your addition number sentences, and some of you might challenge yourself to write that in a subtraction number sentence too. Let's start and figure out what our whole is now. So we have a completed tens room, which is 10, 11, 12, 13. Well done. So we are playing around with the whole of 13. So in your part whole model, you'll have 13 as your whole. What parts might we have? We can see a part of 10 and 3. So that is an option, 10 and 3. And you would write a part of 10, add a part of 3 equals the whole of 13. A part of 10 and a part of 3 makes the whole of 13. So pause the video and have a go with number 13 and see which parts make that whole. Off you go. Keep the video paused if you'd like more time. We're moving on to our third and final activity, and we've done this one before. It's a great activity for us to use our eyes to see whether a number is more or whether the amount is fewer. Okay? But first of all, today we are going to try and figure out what the number actually represents, because we can see we have Numicon showing us what our number is. So we've got part of 10 and a part of, yes, 9. 10 and 9, and that equals the whole of 10 and 9 is 19. Should we just double check that? So we've got 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yes, we've got 19. So we've got 19 represented here. We've got 8 and 1, 2, 3, 4, 5, 6, 7, 8. 8 and 2, good work, which equals, oh, it's number 1 to 10. Fantastic, we've got 10. So we've got 19 is 10. Is 19 more than 10? Is 19 fewer than 10? Or is 19 equal to 10? Which do you think? Yes, 19 is more, because we can see there's lots more fitting into our symbol. So 19 is more than 10. And can we see the symbol here? This is known as our more than symbol. So this is our more than symbol. So if I want to show you that 19 is more than 10, I can write that as 19, can use this symbol, is more than 10. Okay, so that symbol means more than. So that's why we are just trying to see it in this picture. 19 is more than 10. Say that with me. 19 is more than 10. And can we see the big part of our symbol faces the bigger number? Good work, well done. So I'd like you to do this one yourself, because I know we've done this activity before. I would like you to figure out what this number is, and the same with what this number is. And then figure out whether this number is more than this number is fewer than this number, or this number is equal to this number. Okay, so is it more than, fewer than, or equal to? Pause the video and give this a go. Great, so we should hopefully have 10 and 7 is 17, fantastic. So 17, and we've got 10, 20, 22. Great, so 17 is more than, fewer than, or equal to 22. Great, we can see it's fewer than, aren't we? There's not as many in this part as we can see in this part. So again, we can use this symbol, our fewer than symbol, to write 17 is fewer than 22. And again, the big part of the symbol is facing the big number. The small part of the symbol is facing the smaller number. Great work. Oh, a different one. Oh, again, we've got a number sentence this time. What can we see? We can see 9. We can. And another 9. And 2. And what does that equal? Does anybody know what double 9 is? Double 9 is, it's 18. Should we just double check? 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Add the 2, 19, 20. Fantastic. So we've got 9 add 9 add 2 equals 20. So we've got 20 is, oh, what have we got? 1, 2, 3, 4, 5. Oh, so we already know the green's 8. Yes, this is 8, 9, 10, 11, 12, 13, 14. So 8, add 6 equals 14. So as 20 is more than 14, 20 is fewer than 14, or 20 is equal to 14. Which one do you think? Yes, we can see 20 is more than, so I can move more than down into our space. And again, remember, we can use this symbol to show that 20 is more than 14. Fantastic. So the bigger part of the symbol faces the bigger number. Fantastic. And we can fit more in that bigger part. Great work. Ooh, another one for you to be getting on with by yourself. So write your number sentence in and decide whether it is more than, fewer than, or equal to. Pause the video to give yourself more time. Great, so we've got 9, add 5, and that equals 9, 10, 11, 12, 13, 14. Good work for getting that. Then we've got 10, 20, 24. So I'm going to go 20 add 4 is 24. Brilliant. And what do we think? More than, fewer than, or equal to? 14 is fewer than 24. Because we can see by the symbol, we can't fit as many in, can we? So 14 is fewer than 24. Great work if you managed to get that. And our last example to finish with, before you get a little task by yourself, we are going to see this one. So we can see that we've got the numerical shape of, yes, it's the 10. And we're going to add the 1, 2, 3, 4, 6. Great. We're going to add the 6. So 10 and 6 is 10, 11, 12, 13, 14, 15, 16. Good work. So we've got 10 and 6 is 16. Oh, we've got the numerical shape of 8. And another one of 8. What's double 8? Double 8. Yes, some of you know, but let some of us check. 8, 9, 10, 11, 12, 13, 14, 15, 16. So we've got 16 is more than, fewer than, or equal to 16. Great, this one was nice and easy, wasn't it? We're very familiar with this sign here. That is our equal sign. So when we are using 8 add 8 equals 16, that means that this is the same as this. As you can see clearly that it is. So good work if you managed to get that. Your activity now. You have got a couple of number sentences. So first of all, you will have to solve those number sentences. Then you will need to choose whether it is more than, fewer than, or equal to. Okay? And if you manage to do that, could you possibly write it using the symbol from the previous slides? Okay, remember our symbols. We've got more than, fewer than, and we've also got equal to. So see if you can write it using the symbols as well. Pause the video to give yourself more time. And let's check what we've got. We've got 16 is, yes, you're right, it is equal to. Fantastic. And did we get the symbol? 16 is equal to 16. Great work if you managed to get that. We then have, yes, 15. And we've also got 16, so that means, yes, 15 is fewer than 16. And hopefully you managed to get that symbol there. 15 is fewer than 16. And finally, oh, we've got subtraction this time. 17 take away 4 was, yes, it was 13. Good work. And 16 take away 5 is 11. So we also know that 13 is more than 11. Great work. And let's see if we've got that symbol. Oh, what does the symbol look like? Can you help me? Because mine hasn't shown up properly. 13 is more than 11. So 13 is more than 11. Great work for helping me show that correct symbol. But that's it, us done for today. So well done, year one. Thank you for joining me for Maths Skills. I hope you're staying safe, and again, thank you.